Hi everyone. We are Team Nebula, and today we are excited to introduce this language, which is a lightweight interpreter programming language we developed for our course project. The idea behind Nebula was to create a clean, beginner-friendly language which supports variables, expressions, control flows, and loops, which are the core building blocks of any programming language. This is implemented in Java using the version ANTLR 4.13.2. Now coming to the architectural overview. So our project has three main parts. First is grammar definition. The second is AST, interpreter and testing. So we use ANTLR to write the grammar, both Lexer and parser rules in a .g4 file. Also, the ANTLR generates the parse tree, allowing us to focus on semantics. After then, we built a abstract syntax tree and an interpreter using the visitor pattern, which helped us modularly support complex features like nested loops and conditionals. Finally, we created a thorough set of test cases to ensure that parsing, scoping, and control flow all work as expected. Uh, this language supports let for variable assignments, print for output, if else, while, and for loops. Also, arithmetic, relational, and logical expressions, ternary operators for concise conditions. We carefully managed operator precedence and associativity through layered grammar rules, and we also tried to keep the syntax clean and beginner friendly without sacrificing the power.
So the runtime of Nebula is implemented using a structured object-oriented design. At the core, we use two key interfaces. The first one is AstBuilder.java, handles all expression nodes like binary operations, literals, or variables. Second is STMT.java, defines the structure of statements such as assignments, loops, or print commands. Each class in this hierarchy implement an accept method which enables the visitor pattern. This lets our interpreter.java traverse and evaluate the abstract syntax tree by visitor nodes in the modular in organized way. The actual execution logic lives in interpreter.java, which interprets expressions and statements by walking the AST recursively. Finally, the NebulaRuntime.java serves as the entry point of the run .nebula file, which ties the parsing, AST building, and interpretation together into a single runtime pipeline. This layered architecture made it easier to separate syntax, logic, and runtime behavior and allows us to expand features cleanly in the future. Next. Let's go with sample program. Like the first one demonstrate a ternary conditional where x equals to 5 print x greater than 3 with the logic 1 or 0. This sets the variable x to 5 and then uses a ternary operator to evaluate if x is greater than 3. Since that's true, it prints 1. That validates both our comparison logic and ternary expression handling. Next.
Okay, so in the last slide, as we see the implementation of if, while, and print statements. Now in this sample program, we will see the implementation of Boolean operations and for loop. So you can write print true and false and also print not true. And the interpreter correctly evaluates them as false and false, which is correct. And our for loop is implemented in C style syntax as it can be seen, and it correctly gives the output. Next slide, moving to the next slide. This is basically about how to run Nebula, especially on IntelliJ. So first we'll clone the repo and open that repo in the IntelliJ. One will need to configure the ANTLR plugin and generate Lexer and parcel files. Now, after doing that, we will generate the Lexer and parser files by just clicking on Nebula.g4, and from there we will generate the ANTLR files. Now then we'll compile the project by including the jar in our class path, and finally we will run NebulaRuntime.java with a path to a dot Nebula file. And also we have excluded all the system generated files so that it does not create any kind of build errors that can easily be overcome by just following the instructions that are present in our readme file. Next, moving to Utkarsh.
Hello everyone. So I will be talking about the contribution each teammate made to this project. So for milestone 2, Karan designed and implemented the grammar in Nebula.g4, defining rules for statements, expressions, and Lexer tokens, and created testing for loops. Yash Shah created Nebula main.java to parse Nebula source files and output parse trees, and created an initial draft for the contribution.txt file, which is in our doc folder. Rushi Patel configured ANTLR in IntelliJ resolved version and generated the Lexer/parser files, created grammar.pdf, and created sample programs. And I created the sample programs test.nebula and ternary.nebula for milestone 2. For milestone 3, Karan implemented the main runtime interpreter logic in Interpreter.java, uh, fixed relational expression support in AstBuilder.java, enabling correct behavior in while loops, and extended the language with Boolean operators and added a corresponding text file, boolean oops.nebula. Yash created NebulaRuntime.java, the main driver class that loads and executes Nebula programs, authored literal expr.java to represent constants and values, and utilizes Java to handle truthness conversions across conditionals. Rushi Patel implemented a variable expr.java for representing identifier usage, and contributed the base expr.java structure used for all expressions, and assisted in integrating both relational and Boolean operator support into the interpreter, and helped align the AST structure with the grammar output. Lastly, I added binary expr.java to represent operations like addition, subtraction, and multiplication, and contributed to core logic of AstBuilder.java, ensuring the parse trees were accurately transformed into ASTs. And I worked on consistency between grammar rule, handling and structure of expression, and statement model. Next. So in conclusion, we built a program called Nebula, where we implemented grammar to runtime for a custom language, which is Nebula, and we tested major control structures and expression types, and wrote some sample programs to verify that our language was working fine with all those codes. And we also gave hands-on experience with compiler design and ANTLR. We basically used Java and ANTLR to make our project, and it was successful. So now Karan will explain you how to execute the code and the language. Over to you, Karan.
Now I will just talk about how our code works, and basically I will show that how each and every part of the code works. So first of all, in the runtime, whenever you execute the code will go through NebulaRuntime.java, and from there, which is written by Yash, and it is an entry point to our code. Now, what this code does is it will read a dot Nebula file, which then feeds the source code to ANTLR generated Lexer and parser, and hence the resulting parse tree to AstBuilder.java. And this is the core logic which was handled by Utkarsh. this just walks, it will walk that tree, the generated parse tree, and construct an abstract syntax tree of expression and statements. Now from here, literals are instantiated as a literal expression or a binary expression or a variable expression, and every arithmetic, relational, or boolean operation becomes a binary expression or a unary expression. Now the control flow constructs such as if statement, while statement, and for statement are also produced over here. So once the AST is built, execution passes to Interpreter.java. Now, as you can see in Interpreter.java, there are various visit functions. So let's say I have written a print statement. So what it will do is after AST builder, it will come to interpreter and it will go through this, it will execute this function, and the function will implement the functionality. Let's say print statement. So it will implement the functionality of the print statement, and the interpreter maintains a variable environment map and uses the visitor pattern. Each node's accept method calls the matching visit method, as I just explained, and that's how the code will work. Now, moving after this, the code will go to utils file, where we will be returning the boolean or a variable statement. Then from over here, visit variable statement is executed, and visit print statement writes to the console, and visit while statement and visit for statement repeatedly evaluate their conditions and print the output accordingly. Now let's move towards a sample program, which is while.nebula. So as you can see, in while.nebula, I have assigned x equals to 5, and while the x is greater than 0, uh, it will print the value of x. So when I run this program, you can first of all, let me just edit the configuration, and I will just write over here while.nebula, the file that I want to run, and I will just run it from over here. As you can see, it will print 5, 4, 3, 2, 1, which is our expected result. So what this will do is it will go through Nebula runtime. From there, a parser will be generated that will go to AST builder, and from AST builder, it will produce a while statement, and the condition of those while statement will be a binary expression. So a binary expression will say that when to end that while statement, and interpreter will repeatedly evaluate those conditions until the x equals to 0 condition is met, and it will print the values of x accordingly, and demonstrating that the grammar, AST, and runtime are now working seamlessly. So that's it from my side. So this is how the sample programs will run. And this is basically a very brief presentation on how our language works. Thank you for your time. And that's it.